Hi, in this video, we'll be going through the H2 Mathematics 2019 Paper 1. So let's begin. The function f is defined by az cubed plus bz squared plus cz plus d. And we know that 2 plus I and 3 are roots of fz equals to 0. And now we're supposed to find b, c, and d in terms of a. And so you might be thinking of subbing in and solving a simultaneous equations, but that would be rather long, and instead you recognize that it's long and try to think of another way to do it, which is because the coefficients of the terms are real, we know that the root conjugate of the roots of f equals to 0 are also going to be the roots for the equation. And so we know that now fz must equals to a because the coefficient of z cube is a. So you can take out a first. Must be z plus 3 because it's minus 3 here. Then z minus 2 plus I and z minus 2 minus I because this is the conjugate of 2 plus I. So with that, you can expand out and you eventually reduce it to get that fz equals to a times z cubed minus z squared minus 7z plus 15. And so comparing now, this is the az cubed, then that means minus a is b, so b is minus a, and c will be minus 7a, and then d will be 15a. Moving on, for question 2, it says that the equation has the C has the equation x cubed plus x minus 1. And it crosses the x-axis at the coordinate a0. And we're supposed to find a to 3 decimal places. So to do this, you just use your GC and you should be able to get a equals to 0.682 3dp. Now we know that b is larger than a, and the region P is bounded by C x-axis and the line minus 1 and equals x equals to minus 1 and x equals to 0. So x equals to 0 is this line, x equals to minus 1 is this line. Then we just draw a rough sketch of the curve so that we get to visualize where is P. So this is P, and we know no Q is the region bounded by the line x equals to b and part of the x-axis and between A and B. So since B is larger than A, so it's over here. So it's over here, you just draw it roughly. And now we know the area of Q is 2 times the area of P, and we're supposed to find the value of B. So the area of Q is 2 times the area of P, so you just find the area of Q equal to 2 times the area of P. Just integrate from A to B of x cubed plus x minus 1, and you integrate from minus 1 to 0 for x cubed plus x minus 1 for P. Then you integrate this part, you should get x4 over 4 plus x squared over 2 minus x. Very simple polynomial integration. And then you just need to sub in a and b accordingly. And with that, you should get this b cubed, b4 over 4 plus b squared over 2 minus b. And this part will be some number that then you shift this over. And the a you already found from the first part. So you just simplify it quickly and you should get minus 3.10465. And you want to solve this, you just use your GC again because none of this need to be exact. And you get that b equals to 1.892 or minus 1.353. However, because we know b is positive, because it's larger than a and a is positive, we reject this portion, and so the only solution will be b equals to 1.892 3dp. If you have any questions at this point of time, just leave it in the comments. I'll answer them. Next, a function is defined as fx equals to x2 cubed 2x cubed minus 6x squared plus 6x minus 12. we want to show that fx can be written in this form, where p, q, and r are constants to be found. So, okay, so you look at this equation, one common thing is you can take out the 2. So you just take out the 2 first, because anyway here must take out p. So you take out the 2, and then you look at this again. Then, from here you have many ways to do so, but the easiest is to recognize that this portion over here, you have to make it able to be perfectly cubed. And we already know that if you expand a cube, it will be like x cubed plus 3 choose 1, x squared q plus 3 choose 2, x q squared plus 3 choose 3, q cubed. So, and you see 3 choose 1 equals to 3, and 3 choose 2 is also equals to 3. So, this is the x squared, and then you must times 1, and then this is times 1 squared, which also holds. So, the last portion is you need, because this is minus, so the last portion that you will need is this to be minus 1. Because, okay, so how does it work? So it's x cubed, then you plus 3 choose 1 x squared times minus 1 plus 3 choose 2 x times minus 1 squared, which is just 1. So you can see how it actually expands out to be this. So the last one has to be minus 1 cubed. And so you just take out a minus 1 from this minus 6. That means you still have a minus 5 at the end. This part, now you can make it into x minus 1 whole thing cube. And then you just minus 5. So p is 2, q is minus 1, and r is minus 5. And so hence or otherwise, now we are supposed to describe a sequence of transformation. So the idea, so this part you don't really need to write it in the exam, but I just wrote it out to show you the idea. The idea is you want to have x cubed go to x minus 1 cubed. Then you go to x minus 1 cubed minus 5. Then you times the 2. So you first translate it by 1 unit in the positive x direction. Then this minus 5 is outside this thing. So actually you can think of it as the minus 5 go here. So it's y plus 5. So you go in the 5 direction in the negative y direction. 5 units in the negative y. And then the last part, the 2 is outside again. So it's y over 2 in a sense. So you just scale by factor 2 parallel to the y-axis. And we're done. For question 4, now we just need to sketch the graph of 2x minus 10. So you just plug in your GC and you just see the shape of it. Or if you understand already, 2x is here, then you minus 10, you shift it down. So when you modulus it, you just flip it over. So many ways to do this type of thinking. And we're supposed to give the exact values at the point where it meets the axis. So obviously it means the axis here, when you sub x is 0, it's just minus 10, which modulus, when you sub x is 0, here is 2 plus 0 is 1. The 1 minus 10 is minus 9. When you modulus is 9. As for the x here, so it just y equals to 0 now. That means 2x must equals to 10. So x must equals to ln 10 over ln 2. And there will be a asymptote, which is the y equals to 10. Because in the earlier graph, here is y equals to 0. Then when you shift it down, here is y equals to minus 10. When you flip it up, it will be y equals to 10. So now with our calculator, we're supposed to find the exact interval that is less than 6. So here is 9. So 6 is somewhere here lah. So y equals to 6. So you use the graph to actually visualize that the thing less than is just the intersection with these 2 points. So we just need to find these 2 points and then find the range. So when it equals to 6, you have 2 points. You can either cut at the normal branch or you cut at the negative branch. So when you cut the negative branch, you see the x equals to 2, and when you cut the normal branch, you see the x equals to 4. Hence, when you calculate it, it will be just x is between 2 to 4. So I hope this is clear. That's all for this video. I hope you have enjoyed it, and in my next video I'll be going through the rest of the paper, so stay tuned for that. Please like, share and subscribe, and I'll see you again. Bye.